Ja, velkommen til aftenens webinar. Mit navn er Anders Søgaard, og jeg vil gerne på vegne af familielandbruget og inspirationsudvalget i familielandbruget byde velkommen til dette webinar om regenerativt jordbrug. Vi er så heldige i aften at have forbindelse til Dr. Elaine Ingham fra Oregon i USA. Og hun vil give os et oplæg og fortælle om alt det spændende, der foregår i jorden. Der vil efter Elaines oplæg være mulighed for at stille spørgsmål, gerne på engelsk, ellers på dansk. Og så vil Leif Busk, som er med os i aften, han vil være så flink at oversætte til engelsk, så Elaine kan svare. I udgangspunktet så foregår hele dette webinar på engelsk, og vi forventer en varighed på cirka en time og et kvarter max, så omkring kl. 20.15 regner vi med at slutte af. Og så skal jeg sige velkommen til jer, men jeg skal også sige særlig velkommen til Dorte Fløjgaard. And now I'll change into English. We are very glad to welcome you, Elaine Ingham, and I have made an agreement with Dorte Fløjgaard that she will make a special welcome and introduction for you, Elaine Ingham. So, Dorte Fløjgaard, take it away.
Thank you, Anders. I was really planning to do this in Danish just because it is Danish and you know exactly everything that I will tell about now, but I'll try to do it in English now. Welcome to Dr. Elaine Ingham, one of my big idols within the soil creation theme. Dr. Elaine Ingham is a soil biologist and have been working with soil, as I can understand, since the beginning of the 80s, when I was in my first grade. Oh dear. And so you've been working with this for more than 40 years now, especially with the microorganism in the soil. And I've tried to understand a lot of it. I have not taken your course yet, but there's a lot of different names that we are going to learn about today. And I cannot wait to have some of it repeated and hopefully also some new stuff taught to me today. On behalf of Inspirationsudvalget, which is a board that is created by Familielandbruget, we have decided to make a line of talks working on specifically soil creation and also other interesting topics within modern farming. And last time we had Annette Vestergaard talking about the regenerative jordbrug, and she was concluding that reduceret jordbearbejdning, that it was difficult to reduce the soil work without doing it with the conventional. I need a word in English now. I'm sorry. Without the sprøjtegifte og forskellige andre ting, som man vil bruge for at bearbejde jorden og hjælpe med for eksempel ukrudt.
Conventional methods.
Yeah, conventional agriculture methods. Exactly. Yes. And so she actually referred to this talk coming up today, and for that reason, I'm honored to welcome you, Dr. Elaine Ingham, talking about regenerative production of farming soil. And let's hear what good things you have to say. Thank you.
Thank you very much for that introduction. I am honored that you've asked me to come back again and keep expanding the knowledge base for you. So my plan today is to go back over some of the information that I think we covered in the first session, but just to remind everybody, what are the different benefits you should be able to obtain when you're using the biological approach instead of the chemical approach. How do you easily and rapidly do the conversion? Where are you aiming at in the long run? And then I want to get into more specific information about how you determine how much biology you should be adding in and around the plants that you really care about in order to maintain the understory in your agricultural fields. You want to have a particular set of conditions that sets the stage for those protective plants that will prevent compaction on the surface of the soil, so that you don't need to use tillage at all. You don't need to be irrigating your soil, even in very, very dry, hot conditions. I've worked in Australia for a number of years where they were in their 35th year of drought. And I sort of would poke them and say, I think that's called climate change. By the time it's been present with us for 35 years in this fashion. And so we learned that we had to protect that soil surface. We couldn't let any compacting device make it untenable for you to be successful in using the soil food web approach. So going to go through all of those steps for everybody again. So the last part where it's the how much, how do you keep monitoring, what are you looking for? That'll be the new information that I add in this presentation. So hopefully you'll all write down your questions that and so that at the last the last 15, 20 minutes will be question and answer time. 45 minutes. Okay. So I'm going to have to start talking fast. I thought I had a whole hour. Whoops. So on to the slides. So when I look at this picture, not shared, share screen. This is why he always comes along, because otherwise I would mess up. Okay, there we go. So I always start my talks anymore with this particular picture of me in an agricultural field maintained by the university, Oregon State University. And so therefore here we're in the middle of chemical agriculture. And when I look at this picture, I cringe, because I can tell you a really good idea of what the problems are just by looking at the soil. And it sometimes dismays me a little bit where, soils people, agronomists will immediately right off the bat say you have to do all of these tests, all of these money expensive testing that you have to have in order to understand what's going on in your field. Look at the soil. Look at that material on the surface. Can you call it soil? Well, what's the definition of soil versus dirt? Is this dirt that we're trying to grow soil and plants in, or is this soil that we're going to grow plants in? And we're pretty far along the way to this being dirt, not soil. Look at the color over on the left-hand side when you're facing the screen. Look at the color of that material. It's a tannish red, maybe light brown, but it is not the 70% cocoa chocolate color that we want in a good, healthy soil. So right from there, I can tell you that you don't have the soil food web that your crop requires. They're going to be putting in various kinds of vegetables and shrubs and, raspberries and marionberries and things like that are going into these fields. And they need a lot higher level of organic matter in the soil. And for me, the easy, simple way to assess that is look at the color. When we look over on the right-hand side, see the big clods that are not, and I can point to them. There we go. See those kind of blackened, they look very dark and black. Well, that tells you that this has been anaerobic. A compacted layer formed in this soil on that side of the field. And now as they were tilling, that's driving 50% of your populations of beneficial organisms. Whatever amount of beneficial organisms were here before, they're now 50% less. And so how many times does it take tilling the soil up that we really need to change and call it dirt? So in this dirt field, those clods tell you that you have an anaerobic layer that the root systems of your plants cannot penetrate. And therefore, the whole lower stratum of your soil is not available to your plant. And if your plant could somehow get through the compacted layer, it's going to go right into a whole deep layer of there's no water. There's no nutrients being replenished. We don't have the right kinds of microorganisms. They're all anaerobic. Most of the anaerobic organisms in soil are disease-causing organisms. So I can tell you right away just by looking. And this is what we promote in the school is learn about the easy ways, the information Mother Nature can just get to your eyeballs, and you can start to figure out what you really do need to be assessing. You have to be up to date on your aerobic, making it aerobic. What causes soil to become aerobic? So we'll quickly discuss that as we go through the next few minutes, because I got to get going to be able to get to the really new stuff. So biology is the ultimate tool that you can use to determine whether your soil is fertile, whether you're going to have the nutrients you want present to make that a strong, healthy plant. Its immune system can only be turned on, if you will, if you've got the right nutrients present in the soil. Well, where does your plant get the nutrients that it requires? So just some of our team that working with us, you would be working with Rodrigo and Carla, as well as Cade and myself. Other folks help us at times too, so you'll get to know the whole community working with us. Now, this is just the contingent that is in the same town as myself, Corvallis, Oregon, but we have consultants around the world. For example, like Leaf, he's integral part of what we're doing in the Soil Food Web, and so he would be the obvious person for all of you to start working with to take those first steps towards making certain that you don't have to use inorganic fertilizers. You don't need to be putting out pure manure onto your fields. That's actually kind of not very good, because manure, by definition, coming through those stomachs of the animals or the human beings, that's an anaerobic product. And that means it's very likely that disease-causing organisms are present in that manure. If you're spreading disease-causing organisms out onto your soil, you may experience some problems. So why give yourself those problems? Learn and use what you know about Mother Nature to start figuring out. We want to help you figure that out. So Leaf is there to help you in these things. So continue on the way. Okay, there we go. There. Here's the soil food web. So starting with each of the groups of organisms here, we want you to learn what that means if you only have a few. You only have a few bacteria, well, you're not going to be forming the structures to hold water in the soil. And so you need to make certain that you have adequate bacteria and that you have those bacteria that are going to use the exudates coming from the root system of the plant to where the plant is essentially sending out the order of what it needs in terms of nutrients. The bacteria and the fungi say, great. What's in it for us though? And the plant says, well, if you come back with the nutrients, then I'll pay you. But no, no nutrients, no Edie for you. So
excuse me. Okay, now the slides are changing. So good.
Okay.
Just
Yeah,
continue, please.
Okay.
Okay, so not both slide sets aren't turning at the same time. It's just one of them, I guess. And it's this one, so I'll be fine. So looking at the soil food web, I was just talking about bacteria attracted into that root system, follows the directions given to it by the plant, pulls nutrients out of the sands, the silts, the clays, the rocks, the pebbles, the parent material. We have billions of years of nutrients in that soil. And the plant will put out the information that tells which bacteria to go find what nutrient and pull it out of the sand, silt, and clays. The silica bilayers in all of these products contain those nutrients. Well, same thing for the fungi. They are given instructions by the plant. The fungus goes off and pulls those nutrients out of the sand, silt, clays, rocks, pebbles, etc., and comes back into the root system. Sooner or later, the plant is going to need those nutrients. So the microarthropods, the fungal and bacterial feeding nematodes, the protozoa, will be pulled into that root system because look at all the bacteria and fungi, which are the prey of those third trophic level organisms. And so when the arthropods, the nematodes, the protozoa eat the bacteria and fungi, the concentration of nutrients inside the bacteria and fungi is so much greater than the arthropods, the nematodes, and the protozoa can tolerate. And so they spit out into the soil, they poop out into the soil, whatever verb you want to put in there, puts those nutrients, soluble nutrients that are exactly what your plant requires. Your plant doesn't make the nutrients, doesn't make the enzymes to pull the nutrients out of the sand, silt, clays, rocks, and pebbles. You've got the plant doesn't have the ability to do that. And so they've got to rely on the bacteria and fungi. Well, the bacteria and fungi were already here before plants came into existence. So no surprise that nature would use that pathway to get maximum benefit from what's going on. What is Mother Nature trying to do in the real world? So we have nutrient cycling as a very important part. I've just touched on the very most layer, the least layer of all the things that now occur because we can cycle nutrients like this. One really important concept for you to take with you from understanding all these interactions in the soil is this one, the difference between dirt and soil. Plants cannot grow in dirt. because they're not going to have the nutrients, they're not going to have the protection, they're not going to be able to build structure in the soil around them. So all these things that your plant requires only occurs in soil. So we want to make sure that you've got soil that you're working with. Well, organic matter is one of the biggest problems in our agricultural fields. We haven't been putting back the organic matter into those soils that the plant requires. And so the plant doesn't get the nutrients it needs. So soil must contain organic matter, and that's really wide amounts of those different plant materials, because we want as much diversity of organisms growing in your soil that no matter what the temperature, no matter what the nutrient concentrations, no matter what the hot, cold, wet, dry conditions are, we've got to have microorganisms. And there we are in our soil over here, looking at the mineral components. We already discussed those. The organic matter, we want as many different kinds of plant or organic materials, dead bodies of all the critters in the soil, for example. And we have to have the organisms to do all of the work that your plant requires. You try to grow your plant without these parts of the system being looked after, you're going to fail. If you're trying to grow plants in dirt, you're going to have to put in all the different toxic chemicals, and the cost of that to you as growers, the damage that those inorganic fertilizers, those pesticides, those nematicides, those fungicides, all of those different things that are meant to kill are killing you as well. It just takes longer to pick up the effect of these kinds of toxic chemicals in your surroundings that you are consuming as if, because we called it food, there's no problems with it. Well, we've got to realize that that's kind of been a whole messy story about what these big chemical companies have been doing to us. We have to look at a way less expensive way of growing plants where no toxins, no disease, no weeds occur in those systems. So soil requires predators to do a lot of the eating of the organic matter and even the organisms, prey species for your for the soil. And so we've got to have the predators in the system when we're trying to understand how nature works. Okay, next. Both changed, yay. A lot of the times when you talk to soils people, agronomists, they appear to only be considering what is the percent clay, what's the percent silt, and what's the percent sand. Well, I don't know about you, but that would leave me with the desire that, clay, loam, parent material, soil would be, see, it's not really soil because this is just soil texture. This has nothing to do with the organisms in the soil. So this is something you can fairly easily measure, but it's not going to give you that much information about productivity or about the ability to prevent the bad guys coming and killing your plants. So we need to know the exact processes and the exact sets of organisms that do the work. And we must know whether those organisms are returning to a system that was disturbed. Now, all of our agronomy going on, pretty much 99.99999% has been in chemical applications for years on end, and all these problems are developing for those growers. There are hundreds of thousands of hectares of land in the Southeast Asia, in the Middle East, in South Africa, in Africa in general, in Brazil, South America, all of these different places where you cannot grow plants. And why is that? How can some of the most productive soils in the world suddenly become incapable of growing a plant? Because you've destroyed the biology. And what therefore then needs to be put back is the organisms. So when you're going through the scientific literature and you're reading a soils paper that says, these are the important functions that occur in soil. And I go through the rest of the paper and go, well, tell me how you are going to measure the functions that are going to occur in soil. And there is not anything in those publications about how they mean to measure function. They immediately go to individual species or a few groups. They don't consider the whole system. Going back to that field, the first slide, you have to have all these different organisms for all the different work that these organisms are going to do for your plant. You need to know which of these organisms belong to which ones, which type of plant. So we need to know how the functions are performed, and we need to know who does the work to make things happen. When you think about current days, the Green Revolution is an example of a system where they came into them after World War I, after World War II. A lot of the soils in the United States had been unutilized because all the boys and the men were off fighting in the war in Europe. And so there was a period of time that those soils started to recover. In many cases, 10 to 15 years of recovery before we came back to start doing growth of food and do all the things that we want. We prize soil, the correct plants to grow and help out human beings. And so they came up with the Green Revolution because it seemed like when the soil started to not be able to deal with weeds, not be able to deal with inorganic, not be able to, not be able to deal with diseases and pests and nutrient cycling, all of the formation of soil structure, so air and water and can go through that soil, reaching deeper and deeper and deeper. How far down do roots go? So I better hurry up here. So we want to realize that with the Green Revolution, we are just going back to our chemical days once again, not paying any attention to Mother Nature. So the organisms we need are killed by the materials that we add in the Green Revolution. It's what human beings have been doing since before we could write things down. So we need the entire soil food web for plants to be healthy. So before treatments are applied, we need to understand what happened in the past and choose one or two of this list to measure in every project that you're doing. And of course, my attitude is you have to have the soil food web. You've got to be assessing bacteria, fungi, protozoa, and nematodes. And as a consequence of measuring the soil food web, you don't need to be worrying about, how do you measure compaction and puddling events in your soil. We're tracking that by using the soil food web organisms. Watering requirements. Now, how do you get rid of compaction out of the soil? If you don't get rid of compaction, you're going to be putting water into the system, or it's raining and water goes into the system, but most of that water washes off and is now in your rivers and lakes and streams and out into the bays and gulfs and out into the Atlantic or the Pacific or whatever sea or ocean you're dealing with, killing the organisms in those places too. You know, we could choose to look at any one of these or two of these things. Pick the most important measure for your client. What has your client used in the past? So a lot of times we go for soil food web, all of the organisms, the bricks. What is the concentration of different materials in the sap of your plant? We want to know what's going on with the weeds, because if we're dealing with the right conditions, you won't have any weeds. And then sequestered carbon if you like. So monitoring, we're going to pick out very simple, easy to use methods for monitoring these conditions of health. I like to point out, you know, how far down do roots go, because so many people don't believe it. This is a less than a year old grass plant in a golf course. And we had half of it. Half of the area was in biology and the other half was not, was just in their standard chemical approach. And we had green grass through the whole entire summer period, no problem. Look at how deep those roots went. That's approximately 4.5 feet. So how many meters? 3.5 meters. Yeah, so yeah, it's not 3 meters, it's 1 meter. You're very kind not to point that out to me. And so we can make certain that these plants will be alive longer, because all of the water you need in that into the season are going to be is going to be stored very deep in the soil, so that your plant can get the nutrients it wants. So quick overview of why we care about these organisms, and getting back into the system needs to be something that we're doing. So when we're looking at all those things that the plant can do, that was a very quick, brief overview. Looking at succession, where you start from a disturbed system, you know, somebody dug it up for a parking lot and then they didn't need the parking lot, and so they pulled all the concrete off, and your tree and your corn plants are supposed to now start growing here. And wrong, not going to happen without massive applications of all of those things we use in chemical systems. So bacteria typically are the only thing that's growing early on. As those bacteria start to grow, they are releasing exudates for whatever plant. So now we've got moss or lichen or very early successional herbs in here, kelp, kale, things like that. Notice that the bacteria biomass has gone up, and now we finally got some fungi in there. So going in the right direction to grow these plants. Well, these plants are putting out different kinds of exudates, which means different kinds of bacteria and fungi. And now protozoa and nematodes are going to be starting to grow. And that causes the plants to be able to shift. We've got a whole new different set of plant species. Well, they, of course, are going to alter the bacteria and fungi, which is going to alter the soil food web to get all together. And so sooner or later, we have a whole different set. We're going from early successional grasses to the veggies, the herbs, moving on up. We're now here with the bushes and shrubs into the deciduous forest, moving on a little bit. to evergreen forests to the full-on conifers that are huge and wide and tie up the nutrients in the soil, right? Yeah, but there's always more nutrients down there for your plants to be able to come in contact with and solubilize them and get those plants to continue to grow. So we need to know both aspects. What is the bacteria, fungi, protozoa, and nematodes that each plant needs in order to get balanced in the right way? And this form of nitrogen early on in succession, it's strictly nitrates. Now you start building some of the ammonium. Keep that. Can I take 5 more minutes? And then I will cede it over to you. Okay. So the way that we want you to think about the whole system is go out and take a sample. What is there in your soil right now? Are there any organisms missing? And we're looking at it from the point of view of bacteria, fungi, protozoa, and nematodes, the good guys, the beneficials that we see in that soil. And so if we're missing a large amount of the biomass of the beneficial bacteria or a large amount of the fungi, we know that we've got to inoculate that soil with organisms that are strictly beneficial. Maybe there's a
Jeg tror, vi mistede forbindelsen til Elaine Ingham her. Jeg ved ikke, om du havde en forbindelse live på Skype, så du kan give hende et kald.
Jeg har forbindelse. Jeg prøver lige at se, om jeg kan få fat på hende, og det ved jeg ikke, om hun har opdaget. Okay. Jeg vil sige, hun er i hvert fald inde her, så jeg tænker, hun kommer ret hurtigt tilbage igen. Kort som er ham IT-manden, han har i hvert fald normalt nogenlunde styr på tingene, når vi har møde. Hvis ikke hun svarer her, så kalder jeg lige for hende. Men det var lige lidt ustabilt. Der er en par gange, det skifter rundt, så det kan altså godt være internetforbindelse. Desværre, må jeg sige.
Nu kommer hun.
Okay, ja. Okay.
Okay, now you found us again? So that's what the little bling means.
Welcome back.
I'll know for the next time. So I'm going to back up just a little bit and hit a really important high point. That once we come into an ecosystem, we know we're going to take over because it's going to be less expensive. It's going to be more conducive to building stronger, better plants with more nutrition, etc. So how do we go about this? We first want to determine what organisms are missing in the soil. So, say you go back up to the picture. Yeah, I can't move the slides. So determine what organisms are missing in the soil. So if you're trying to grow corn and what's actually in your soil is a mixture of microorganisms that would grow broccoli just fine, shouldn't you know that? So that you do the proper thing. Let's grow broccoli in this field, in this patch, because that's what the soil is capable of producing without any trouble. Whereas with the corn, we're going to have to go get our compost piles and get the organisms so that they're ready to be put into the soil. So, with a corn, we need a lot of fungi. So equal biomass of fungi to bacteria. We need a lot of protozoa. We need a lot of nematodes that eat the prey species of nematodes, and the nutrient cycling is going to be going on correctly. The plant is going to be informed that it's under attack, and the plant puts out its barriers. The plant gives nutrients to those organisms that grow deep down into the soil and protect your water source, protect oxygen, all of these factors. So we want to be looking at what's missing in the soil and then adding the proper amount of the biologically complete compost that has all of the organisms that are missing in the soil. So now you don't have to apply this as a compost. If that's really beyond your means, then think about taking a small amount of the compost and extracting out the organisms, maybe add a little food for those organisms, and out you go, and you spray your fields. I like to encourage everyone to start using droids, because then you don't have big, heavy equipment driving up and down the rows, compacting everything it squishes. And so up to you on how you want to do some of these additions to the soil, additions to the compost, addition to the teas. Now the teas are meant pretty much just for dealing with foliar problems. And so having that as a backup, you can always go out at the last second and go, oh, we've got some mildew showing up between rows 13B and 13Q or whatever. And we'll apply that compost tea to an area about double the size, where you can see that the disease is starting to take hold of. But as soon as you coat all of those layers, the above ground and the below, from the ground up and from the top down, you want to make sure you get both sides completely covered with these beneficial organisms. And it's usually overnight that we exit the diseases. The fungal diseases are very simple. They're very easy. We're starting to work with TR4 in various places. And, the TR4 is supposed to be a completely there's no chemical compound that can kill and shut down certain species of disease. And yet when we put the biology out, we deal with the problems. So addition of the organisms are typically only required once or twice. You put your biology out, let it have a week, 7 to 14 days, and it's hard when there's somebody else talking in the background, sorry. So we want to bring the balance back to what's correct for your plant. So you have to be working with us to know what the correct balance is that we've found for cold environments or tropical, or you have a lot of cloudy gray days versus bright sunshiny days, and then you have huge amounts of rain that fall for a short period of time. They all require slightly different things. So the addition of these organisms are probably required only once or twice. So you convert the biology that's in that soil to something that's going to keep your plant alive, benefit your organisms. So microscopes are used to assess life in the soil. So keep going. You know, what does your plant need? And so this just exemplifies one of the handouts. What is the ratio of fungi to bacteria that your organisms should, you know, part of this, if you want to grow weeds, this is what you should have in your soil. Notice that there's
Dr. Elaine, I think you're
Mhm.
meant to have some slides on, and they got off since you went offline. So we cannot see what you're talking into.
Okay. I don't, Cade is not in the building right now. Cade?
Should I help you?
Yeah, if you know how to fix it. Here comes.
Okay.
Here comes Kate. They're not seeing the slides anymore. And here I've been talking to these slides.
It has been okay so far. No problem at all.
Can go ahead if you need to forward it. Do you guys, do you have, can you see the slides on?
Yes.
We are looking at
Yeah.
that. We say know the balance needed for each crop and cover plant.
Okay, so I'm trying to get this finished up really quickly because I think I'm a little over in time. So typically, when you're coming to a field, we want you to go out in at the harvest time, because that's where the soil will have all these nutrients, have all of this food for these beneficial organisms to grow. They'll have all winter long to start doing all the processes, fix all the problems. So when springtime comes and you're going to plant your plants, 2 weeks before you're going to plant your plant, you do an assessment of the biology in your soil. You know what the biology is in your compost pile. So how much of your compost pile needs to go into your soil? And the first time you do it, yep, you're gonna have to put in, fairly high level of application. If you can't really do that, you turn it into an extract. And with extracts, you can extract nutrients out of maybe 300 pounds of your compost, extract and get enough of those organisms that you will be able to just once go out and apply that to the soil surface. You may do that in conjunction with your seeds because you want to protect your seeds really to the maximum degree, and that's this same process will do that for you as well. So a little bit difference. I was just talking about the difference between temporal and tropical systems. Tropical systems, you have crops being harvested throughout the whole entire year in some places. The opposite extreme is temporal, which I think is more what Denmark is all about. So typically, you're going to go out in the spring, take a sample, how much of the compost needs to go into the ground, which is the easiest way for you to put this material into the ground. Get it out there, give it about 7 to 10 days, sample again, find out what has increased massively. So now you don't have to worry about that organism anymore. Well, what's going on with your fungi, with your protozoa, your nematodes, and then look for balancing that. And so we do give you some ideas of how much of the organisms you should have. So the minimum organism values for soil, well, if it's beyond, if what's actually out in your field is way below this minimum value, you've got a lot of work to get the biology back into that soil. It still should only take you 1 or 2 applications So as long as you follow directions, this is going to work quite easily. The compost, you've got to make sure that that compost you're making is going to fill in the ranks of all the organisms whose numbers might be too low. So here's the minimum values. Don't bother putting something out if you can't reach at least these levels for the organisms. You're just not going to get benefit enough. This is the minimum. Well, you could always take the compost, if you have the compost at this level, and extract it once, pull out that liquid material that has a lot of the organisms in it, and use the same liquid, but now with a different aliquot of your organisms in that compost. Extract for a second time. Now you've perhaps you've doubled, maybe close to half as much as you had before. Well, that's not really enough. Maybe that's what you'll find. So do the extraction again. Yeah, great. We're up over what needs to be. And then we want to, do you see the, they're not both linked together anymore. Are you seeing the biological succession? It's just back up here. Yep. That's okay. So you've got an inoculum, the extract that you've made certain that it's above some particular level. So you're getting the ratio of the fungi and the bacteria up to what it needs to be to select for the growth of the plant that you want. Now, we have lots and lots of studies like this one, and like Leaf is working on this one. I believe right now he's right in the midst of it. And you could be maybe going out to his field, see what he's doing. The same for any of our students. They have to go out and do a field trial so they understand what needs to be done. When they go out and apply this food, what happens to the organisms? Only the fungi were improved, or was some of the bacterial community also improved? What did it do to the beneficial protozoa or beneficial nematodes? So the groups that we want to do. So I should probably stop at this point. Next time I promise I will get to all of these comparisons of the with the control, for example, and this is was with veggies in Spain. You can see that the control treatment with the chemicals in it versus compost that these people bought from a close operation, and they called it compost. And I think if you looked at what was coming in, that was not compost. It was smelly. It clearly had manure of some kind, completely undecomposed. The anaerobic conditions, high, kind of middle heat temperature, just increased the growth of the pathogens and not the good guys. And so the effect with that kind of compost, you can see that really it's not much different from just going with the chemical agriculture. Not really improved at all, and in some cases, really significant disease that you're leaving for next year's crew. But what happens when you use a really good compost, biologically complete compost? Look at how much higher most of these organisms were, and the results in these comparisons, this compost always, I think maybe there was one case that, I can't see it now, but they're all higher than the control or the purported compost. So that's what we expect, and that's what we've learned. Now, I would probably say to him, you want to get understory crops, understory cover plants in between your rows, because the rain pounding down on this soil in the middle of those summer rainfalls is not going to be good for the longevity of these sets of microorganisms. So can I just have you, should I finish now and let's do questions and answers?
Yes, I think that'll be fine. It's nice to see the results and the yields here in the test, because that gives us an idea of how it's working.
Yep, and every single example here is so the keyline plows, where we're getting the organisms very deep down into the soil, 3 feet, 4 feet down. Then you don't end up having to do sprays above ground. And you can see with that keyline compost, percent, this is the control, the purple, the bluish purple, percent moisture, 19%, as opposed to holding 50% of the soil was in aggregates. That meant they did not need to irrigate through the dry summer period. And look at the difference in production of hay. Look at the difference in production of grapes. The difference between 6 tons of grapes for wine production as opposed to 7.5, a full 1.5 tons more grapes. That was just golden money in their pocket, because they can, get a really good case study of tomatoes. This is the owners of ZZ2 in South Africa. We've been working with them for a long time, probably 6 to 7 years ago. They kind of said, we can do it all ourselves. We don't need you. Well, every once in a while, they pull a consultant in and we help them out. And then they go back to, yep, it works. So their initial site assessment was, there was nothing in here worth anything to benefit you. Lots of things that were going to spell total disruption. And that's what happened with this, with the control in this system, is it was wiped out by root knot nematodes, Maloidogine. It had aphids on it all the time. It was clearly attracting the pests and the problem organisms. But where we applied the proper set of biology, got it, compost on the soil surface. The tomatoes were planted in that row. No diseases, no pests, just massive amount of production. They now do not rotate their crop at all, because it's absolutely not necessary. If you're putting in compost, you don't have to go through rotations, because you're rotating the soil. Is kind of the way I think of it. We're putting back what was missing. And so that means you don't have to take the things that you're going to get the tomatoes to grow up on the vine. You don't have to move them all the time. So best continuous tomato crop was the best that they could do. Continuous cover crop for, don't need to have to do rotation. In the second year, well, let's take a look at the conventional ag. Only 18% of their materials were first grade quality, and that's the market they tried to get into, because that's the top dollar. Restaurants in all the different cities, towns, large towns, that was their clientele. But when only 18% of your yields are the grade, the quality that the restaurants absolutely have to have, they weren't going to get very far. As soon as they started using the biology, 50% of their production was first grade quality.
Okay, Dr. Elaine Ingham, I think we should try to end now and then open for questions from the attendants to hear if there are any questions around. So please use the chat or raise a hand, then we will take you in.
Yes.
Live.
I have at least one. I think you can also see it, Dr. Elaine. We're starting from Henrik, Henrik Petersen, and he's saying the Danish legislation requires slurry to be kept anaerobic. How can we deal with our vast amount of slurry without losing a lot of ammonia that can cause whatever? I don't know, I can't say anything. in the waterways and sea. We have a lot of pollution problem in Denmark because it's a small country and there's a river and so on. So this is so. Have you got a take on that? I think it's just to make compost, of course.
You do have to make certain that you're getting that biology back into your fields or wherever you're going to be releasing the waste material from whatever kind of production. We've done manure lagoons this way. We have been dealing with people who have severe they don't really know how to get rid of the contaminated water that comes out of certain businesses, contaminated water that's coming from the towns. They all don't quite it's not easy for them to come up to the proper lack of diseases and pests and problems and excess nutrients of some kind. And so the answer is to either run your polluted water through a composting operation. You need a lot of compost that way, or we can take the compost extracts and apply them to the lagoons or to the holding areas and get rid of certainly the organic material that will be causing a problem. We want to make sure that it's always going to be aerobic. And so bubblers of some kind or tumblers of another kind. So we're trying to work with people doing those kinds of approaches, which one works better for which conditions that are going on. Make sense?
Okay.
Okay.
Further questions?
Yes, I have one here from Andreas, and he's asking, what are the best practice for creating high quality compost that supports a diverse soil food web? Can you discuss any common mistakes in composting and how to avoid them? That is for the next week, but you have.
Yeah, I figured that. Yeah, we'd get through, here's all the background, and now down to next time I come talk, I can certainly do all of it, but I'll give you the short version today. We want to make certain that the compost pile is aerobic at all times, because the majority of the aerobic organisms are going to be beneficial. They're going to be good for the crop that you're trying to grow. You don't want it to go anaerobic at all if you can help it. maybe a little bit on the reduced oxygen side right after a heavy rainfall, or you're not quite done tilling up the land for the last time ever. So you get some problems with, the rain came before you were finished. So we're going to go out again in those areas and go through and do the tillage. But this is tillage for the last time. You have put a layer of the compost or the extract on the surface of what you're going to till in. So you're mixing all those good, healthy organisms into your soil, letting it go as deep as you possibly can, opening up the airways and passageways to allow the beneficials to grow down into the soil. Some people don't really realize how deep roots of plants go, but there's at University of Iowa, they just did a challenge of people where they wanted to see how far down a particular species of shrub, short shrub, put its root systems. And the winners of the competition was, I think it was something like 45 feet roots underneath the small plant that was no more than probably 6 to 8 inches tall. So we want to get those kinds of situations into your soil, because that means it stays aerated no matter what. So with the compost, then, that's one of the overriding principles that you've got to pay attention to. When you walk up to your compost pile like in the morning, and you open up the tarp that you put on it to prevent water or rain or snow melting and waterlogging your pile. Well, if you're waterlogging your pile, you are probably going anaerobic very rapidly, because the organisms can't move through a layer of water very fast at all. And so the organisms rapidly growing in that compost on all the great foods we put in there for them, they're going to be operating so rapidly that the oxygen is going to be used. Oxygen drops, all the beneficials hang it up. Yeah, not going to grow here. So you're going to end up with a bad product both ways. You want to make certain that you don't allow your water to become, your compost to become waterlogged. There's another overriding principle. And you don't want to be turning more than you actually have to turn, because think of what turning does to your compost organisms. The fungi are long, thin tubes, and as you turn that and turn it and turn it and turn it, you're just slashing those fungi to nothing. Every time you turn a bit of soil, you are reducing the organism level by 50%. So don't turn unless you absolutely have to. And when the compost starts getting too high in temperature, you have to turn it. Get the oxygen back in there, slow the organisms down a little bit more. We want things that are going to level out, and then eventually on the second or the third third or fourth turn, we want to see that temperature starting to ease down. Well, what's the cutoff for that temperature? As soon as you're above 131 degrees Fahrenheit or 55 degrees Celsius, you are now cooking those organisms that don't tolerate that high heat very well at all. And of course, those are the disease-causing organisms for the most part.
Okay,
so
we have got 2 more questions, and then I think we need to end up this webinar. Will you take the next question from Kurt Oxlund live?
Yes. Does biochar make sense you could add it to your compost. I have heard that the biochar is a good thing for the microorganisms to live in. I think that's sort of the question.
If the question is just about finding a home for the microorganisms to live in, then biochar does do a good job there. But there can be, and here's the danger, there can be some really toxic things that are produced when you put your woody material into the into the biochar production. You can have some really nasty toxic things in that biochar. So you got to test things. You've got to be absolutely certain that the person making the biochar for you is not falling short for any reason. Because it's, if you're adding this material to the biochar and it's got a really nasty toxic compound in it, and there's only like 65,000 different toxic materials, so I can't really go through a whole list for you, and still be here in a week from now. So it's one of the things we've noted that is really good for putting biochar in is whenever you have a compaction layer, because the biochar has a lot of features to it that will keep oxygen and water, organisms, roots, whatever, growing through the soil. So there can be a really good benefit of putting in biochar if you're trying to grow something in sand, if you're trying to grow in something in silt or clay, the biochar can be very good at solving that one problem for you. But please check to see how they processed first.
We got that point. Then we have a last question in the chat, and then one from Sven Jonsen. Take the last from the chat live.
Okay, from Sophie, do you have any results of development of the soil fertility, microbiological activity of grass field or grazed holistically, holistic grazing?
Yeah, the two things of holistic grazing go together very nicely, because if you've got good soil and the animals are moving inocular around that field, you're improving the diversity of your soil all the time, because the animals are always bringing back in new and different kinds of organisms. The bad guys are going to be outcompeted, consumed, don't have to worry about them. But the beneficials for which this is the right environment for them to grow and proliferate, definitely good synergism between the two. So I could go off into, a 2 or 3 hour lecture about this.
Okay. Very good. We look forward to that. We have one final question, and this time we will let Sven Jonsen in. Sven, come in and give your question.
I don't know if he can hear. He doesn't seem to be there. Oh, it's coming. Okay.
Coming, Sven. You have to unmute your micro.
Ellen, Svend han kan ikke få mikrofonen på. Du har ikke gjort det samme ved ham, som du har gjort ved os.
We will have our technicians to try to unmute. Sven.
Can you unmute this person? Do you know how? I don't think you can, because we're here and he's in.
Yeah, we need to have Ellen back on track if Ellen has not.
Ellen is working on it.
Yeah. He has the license to make a question. Yes, he has. So can you unmute your own microphone, Sven? No?
Up in the right corner, you can't do anything.
Upper right-hand corner.
Or then-
Ellen, his icon is the same as when I was trying, and you said I
Yeah.
could, but I couldn't. So you need to do something different.
But can he write the question? Then we will try to take it from here.
Ja, så. Ja, altså nu...
So
Sådan,
I think there's.
Yeah,
Yeah.
you are
Floor.
you're through. Come on, Sven.
Okay, great. Thank you. Elaine, you said that that the compost tea were mainly used for foliar application. What about treating the seeds before planting or drilling?
You don't, if you are going to use those seeds the very same day, then a tea could be appropriate. But if you're going to treat the seeds with a mixture of really good sets of microorganisms, and then stick it in a container because you're not going to plant until next week or the week after, you're going to lose all your seed because the microorganisms haven't been put back to sleep. You got to convince them to go back to bed. Well, that is really hard to do when you get a good bacterium or a fungus and they've tasted those seeds. Yeah, you just, no, don't mix the two of them together until right as you're going to be putting the seed in. So like in a planter, you know, you have the tank that's got the compost. It could be tea if you want it. I just find tea as one more step that I don't need to be taking. So I usually just do the extract. It's a lot more controllable. And you're going to be perhaps putting in a little bit of food to wake those bacteria and fungi back up. And of course, as soon as you put those organisms into the ground, you've got those bacteria, fungi, protozoan, nematodes that like those cold conditions or hot, what time of the year are you in? Usually typically in the springtime, you're putting on those organisms on the seed surface and then you want them to go.
Okay. On behalf of the Danish family farmers, I would like to thank you, Elaine Ingham, to take your time to make our listeners here to learn about the regenerative agriculture. I think there's a lot of interesting points in that, and it's very inspiring to listen to you. And we hope that you will come by Denmark sometime. We heard that Dorte will be ready to support you. And also thank you to you, Leif Busk, for giving a lot of good help to make this be a success. And then I just want all of your listeners to have a nice evening and go out and do a lot more for the good life in the soil. I think that should be the final word. So thank you very much. Thank you for tonight, and go out and let it grow.
Yes, enjoy those critters.
Okay,
Thanks.
thank you very much.
Thank you.
Thank you. Thank you.
Ciao.
Bye.